Okay, so the theorem we just proved, is called the triangle mid-segment theorem. Triangle mid-segment theorem. I have the other line for you. If we connect two midpoints of the triangle, it ends up being parallel to the other side. And that mid-segment ends up always being half as long. Okay? So knowing that, let's look at title this one example 1. What are 3 pairs of parallel segments on our triangle? Connor?
RS and DF.
So RS is parallel to DF. Let's make sure we know where that is. Where is RS on the triangle? This is called a mid-segment. R is the midpoint. And we know that because there's one tick mark and one tick mark. You can't just assume that it's the midpoint. You actually have to know it's the midpoint. So because we have 2 congruent segments, we know it's the midpoint. Over here, there are 3 tick marks and 3 tick marks. So what does that tell you S is? The other midpoint. And when we connect midpoints, that creates a mid-segment. Okay? That segment, mid-segment, will be parallel to DF. How do we mark parallel lines? It's a little arrow. So I would put an arrow here and an arrow here to show that those 2 are parallel. Yeah? Oh. Okay. Okay. Thanks. Okay, so there are 2 more parallel lines. You got the last one, so the last one else. Fine. Can you see any other mid-segments? Because if there's another mid-segment, we must have another pair. Okay? ED. Okay, this ED. Those must be parallel to ED. ST. Is S actually a midpoint? Is T actually a midpoint? Yeah, because we have the 2 tick marks, the 2 tick marks. So ST is called a mid-segment. We have midpoints, and when we connect them, it's a mid-segment. So ST, make sure you know how to notate. It's a segment, you put a bar above it, parallel to ED or GE. Okay? So let's do that marking. I'm going to put 2 arrows on this one because it's a different set of parallel. Yep, mark it. So on the green ones I did 1 arrow, on the red ones I'm doing 2 arrows. So because it's a triangle, I'm kind of going to say there must be a third pair. Triangles have 3s of angles, 3s of sides. James, can you see a third pair of parallel right segments? Okay, and then let's make sure that RT is in fact created by midpoints. Is this a midpoint? How do we know it's a midpoint? 1 tick mark, 1 tick mark. So we're good. How do we know T is a midpoint? 2 and 2. So they're congruent. So James S or RT has to be parallel to what side? Yeah. Good. And so we mark that with 3. 1, 2, 3. 1, 2, 3. And it creates this cool little triangle inside. Well, if you connect all 3 mid-segments, it creates a triangle. EF. Okay? So you have to list them, you need to make sure you have 3 pairs. Okay? T is a triangle XYZ, but it doesn't give you this triangle. So for our purposes, we're probably in our best interest to draw a triangle. So draw a triangle. Sure, let's do a right triangle this time. Okay? And label the triangle X, Y, Z. And you basically do the same angle so we all know what we're talking about. Where the x's are all the same angles. Okay? It says A is the midpoint of xy. Bella, can you tell me where I can find the midpoint of xy? The middle of what? I don't know saying. Xy. So tell me where I hit the middle. About here? So we should label that A. Okay? B is the midpoint of what? YZ. So find midpoint halfway of YZ. Label that B. So the midpoint. Now, we should probably show that the midpoint. I'm going to do one tick mark, two tick marks, two tick marks. We'll say much next to each other like that. That means we found the midpoint. And C is midpoint of XZ. So how would I show that this is actually a midpoint? Three tick marks. 1, 2, 3. 1, 2, 3. What are three pairs of parallel segments? As a pattern? Oh, to connect CD, because of our mid-segment theorem, it's parallel to what, Isaac? Sherman? XY, good. Parallel to XY. That's why we really should draw this picture even though they didn't give us one, so we can visualize what's going on. Okay, that can you see another, and I'm going to mark the parallel. One arrow, okay? That can you find another pair of parallel segments? AB, okay, just say diagonal one. So you say that's parallel to what? Good. And we know that because we already know B and A are midpoints. Okay, they have to be midpoints or this doesn't work. Sheldon, can you give me the last pair? CA. Good, the BY. 1, 2, 3, and so mark them all. I didn't do my 2. Okay, that's the mid-segment theorem. So you need to know midpoints, and you need to know mid-segments. Any questions? Okay, now there was a second part of the theorem that said that mid-segment is half the length of the third side. Okay, so knowing that it's half the length, we can solve for missing lengths. So the next one says, triangle QRS, which you have over there. It says TU and B are midpoints. Well, if they're midpoints, let's draw some tick marks in. If QT gets 1 tick mark, where else should I put 1 tick mark? TS. If SB gets 2 tick marks and B is a midpoint, where should I put 2 tick marks? BR. Got this on your paper? Okay, and same with QR, or QU is 3, so UR must be 3. So since we have midpoints in a triangle, we should get some mid-segments. We use our mid-segment theorem. What is the length of, let's start with TU. TU is right here. Let's do a different color, in blue. TU is right here. First of all, you know something is parallel to TU. Veronica, what's parallel to TU? The whole thing, though. Yeah, SR. You know, this whole thing is parallel. You also know something else about those two. That will help us find the length. For that, TU is half. Good. The bar is 40. How long is TU? 20. See? Easy. So, TU is 20. And it's not a degree or anything. We don't know inches or feet, so we'll just put 20. Because it's half. Okay, let's find another one. How about UV right here? UB, you have to identify which side is parallel to it in order to do this. Okay, Isaac Nielsen, what's parallel to UB? Good, QS. Do we know anything about the length of QS? It's 50. Okay, so Ron, if QS is 50, what's the length of UB? Perfect, right? Just half of it. Easy. UB is 25. Does anyone have a question? Okay, one more then. I'm missing this one. Oh, actually, we know this one. TB is how much? 30. So Emily, what is parallel to TB? QR. So looks like we're trying to find the length of QR. So Emily, if TB is 30, what's the length of QR? Ah, did she half it this time? No, she doubled it. Why do we double it? Because the middle one is half. So we knew the middle one. We're trying to get the bigger one. So that would be 60. You have to double it. Okay. Here's one for you to try. But we should put some, we have the triangle already drawn, so before you try it on your own, we should put some information. In the data, right, AD is 6. So maybe should we write 6? I would recommend writing 6. So it's only this partial part from A to D. DE, this diagonal is 7.5, so I'd write it on there, 7.5. Okay? Find the length, we're going to start with the first one, of DC. We're going to have that length filled up in the air. What's the length of DC? Hold it up in the air when you know it. Good. Okay. Rebecca. Sorry, I had to bring down. How do you know that DC is 6? Yeah, those two tick marks means they can do it, right? So that must also be 6. Okay? What about AC? Put out there when you know the length of AC. Length of AC. You can do a digit at a time. There you go. I used to do that first, but yeah, there you go. AC. How does table? What's the length of AC? You know that one's 6, and that one's 6. AC, oh, yeah, you got it. AC has to be what? 12. So 1, 2. Okay, I would write it on here. As you gain information, I would add it to the picture.
That one, all over the ground, so I enjoyed it, so I went around the school.
Ew. That's why I don't use student bathrooms, because that's really gross.
Now you know something.
Okay, yes, EF. EF, that's the length of EF. Put it up in the air. Find EF. Good, I've already found it. Find EF. What is the length of EF? This red one. How do we know that, Jada? The parallel. But the whole thing, AC is how long? 12. And half of that, exactly. Half of it is 6. FE. Okay. And one more. AB. AB, we're up in the air. How long is AB? AB. Good. Uh-huh. AB. A to B. Okay. What'd you get, Sean? 15. Good, because we times by 2. We know DE is 7.5, so its parallel side must be twice the length. Twice, so 7.5 times 2 is 15. Okay? That's the mid-segment theorem. List the internal sides and be able to find the lengths. Can you do that? I think you guys are doing pretty good on that. Okay, let's go to the next page. Last problem, mid-segment theorem. A geologist wants to determine the distance AB across a sinkhole. Do you see AB on the picture? Make sure when it gives you information, there's a picture, you start, then you can know where that is on the picture. Choosing point E, out here, outside the sinkhole, she finds the distances, so she finds AE, so the sides of the triangle. She finds the side of the triangle on both sides. Then she finds the what? Midpoint, B and C. Okay? Then she measures CD. How long does she find CD to be? 46 feet. So, please figure out for me how long across the sinkhole is it going to be. How do we get 92? Add 2 36s or times the 2. It's double. So 92. Easy. You guys got it. So AB, make sure you put the bar, is 92. Now this is a story problem. What should I add? Feet, yeah. And that would be great if you put it across the sinkhole. Okay. Okay. Let me tell you what a perpendicular bisector is. Okay, bisect means middle, right? Through the midpoint. What's perpendicular mean? Plus side intersects at what angle? 90 degrees. So you already know what a perpendicular bisector is. We're just going to write it. If a point is on the perpendicular bisector of a segment, if a point is on the perpendicular bisector of a segment, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Then it is equidistant from the endpoints of the segment. We'll draw a picture so you know what I mean. If the point is on the perpendicular bisector of a segment, comma, then it is equidistant. What does equidistant mean? Equidistant, so congruent lengths from the endpoints of the segment. Okay, so essentially, this is it. If we have a perpendicular bisector, so if this is A and this is B, and if it's bisecting it, then AC would have to be congruent to CD, right? Has cut in the middle. And perpendicular means they intersect at a 90-degree angle. So to a square. Okay. Those are perpendicular. Then any point I pick on this perpendicular line, whether it be this point, if I put it to the endpoint, A and to B, don't say that they're going to be congruent. But what if I pick a higher point? What if I pick this point right here? and connected it. Would that segment also be congruent to this green segment? Yeah, so the perpendicular bicycle goes on forever. So you can pick one up on the ceiling, drop it down to AC, and those two would be congruent. Okay? So that's the perpendicular bisector theorem. So we need to find out that the two sides there are congruent. It creates a triangle, doesn't it? Okay, so it can help us prove that triangles are congruent sometimes. The converse. So anyone know what the word converse means? We've talked about it a few times. What? Oh, who else are talking about shoes? No. No. It means reverse to zero. Reverse to zero. This means that if there's a perpendicular bisector, then the segments created are equidistant. Okay, we're going to reverse it now. If the point is equidistant, then we have a perpendicular, what? Bisector. So that's the converse. Just remember it. If a point is equidistant from the endpoints of a segment. If a point is equidistant from the endpoints of a segment, then there's a perpendicular bisector of the segment. Then it is a perpendicular bisector of the segment. If the point is equidistant from the endpoints of a segment, then it is a perpendicular bisector of the segment. Okay, and this next one's similar. We'll be talking about angle bisectors. Cut what in half? The angle. When an angle is cut in half. So a line shooting out through the middle or a ray shooting out through the middle of the angle. Okay, so an angle bisector. Oops, maybe put the right one. Well, these two both have the same picture. Okay, if a point is on the bisector of an angle, if a point is on the bisector of an angle, if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. That is similar to the perpendicular bisector. Then the point is equidistant from the sides of the angle. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. Okay, let's see a picture. Angle A, yeah? What is the bisector going to cut the angle? Through the middle. I was a little off and right in the middle. Still a little off. I'm going to cheat. No, except for Mary Poppins. Pretend that's in the middle. I tried. Okay, now if we pick any point on this perpendicular bisector, say I pick this point. shortest distance to get to the right above? Straight up? That doesn't have to do with what I'm talking about. She's practically perfect. Okay, we need to continue. What's the shortest distance? Straight up? Nope. Straight left? Nope. Perpendicular angle is the shortest distance. You don't perpendicular, that length, but since I can't apparently bisect an angle by hand very good, it should be congruent to this one's bisector. It's a little bit better. Okay, and this one perpendicular, those lengths are congruent. That's what it's saying, is equidistant. Any point we pick, and they connect it out to the sides of the angle, they're going to be equidistant away. And it creates perpendicular intersection there. So let's take one way out here. Could that distance still be congruent to this distance? Yeah. Okay, the column is reversing that. The angle bisector says if we have an angle bisector and a point on the angle bisector, then we have equidistant lengths. So the reverse of that, I'm not going to actually write it out, but the reverse of it is if you have equidistant lengths from a point on the interior of an angle, then it has to be an angle bisector. Okay? Let's use that information to answer the next problem. What is the length of A to B? What? What is it? How do you know that x equals 1? Interesting. Okay, you can't just know. Let's say something we do know. Maybe we can do this to column weights. Statement. Reason. Nothing was given to us other than the picture. I guess we, okay, a statement. What's something like any information that goes on the picture? They're given without numbers. The tick marks. What's the tick marks between? AB and DC. Those tick marks tell us those two segments have to be congruent. Should I really have this written down? Given. Okay. I also know something about another side of the triangle. We'll get to that one in just a second. One for idea. What do we know about another side of the triangle? Not still numbers. Yeah? The right triangle? Okay, we'll get to that in a minute. But what about another side of the triangles? You don't know that yet. I'm looking at B to D. Do both triangles have B to D? Do both triangles have B to D? Yes. So can I say B to D is congruent to D to B? How do we know that? Reflexive property. Okay, so we have one side, two sides, and Brayden mentioned something about an angle a second ago. We have a right angle, which means this is a perpendicular, and bisector. Isn't that a perpendicular bisector? Wouldn't this also be 90 degrees? How do we know that that's also 90 degrees? No, not reflexive property. Show you an S. So give it an S. Supplementary. If this is 90 and this is a linear pair, makes a line, this one also be 90. So we now know that by side, angle, side, these two triangles are congruent. our older knowledge to show that these two are actually congruent and equal to each other. So we have a theorem now because we have a perpendicular bisector. This bisects. Point B is a bisector and it's perpendicular. Remember, any point on a perpendicular bisector brought down to the endpoints have to be congruent. That was the theorem. Any point on that perpendicular bisector brought down to the endpoints has to be, both sides that create a triangle have to be congruent. So we can go a long way and prove that using all of our information about similar triangles, or we can identify the perpendicular bisector. So now we know that 4x actually equals 6x minus 10. So what's the value of x? No, doesn't know you got it. What does x equal, guys? How do you find x? Zach, how do we find x? Okay, get our x's together. Minus 6x, so we have negative 2x equals negative 10. By what? Good. So we get x equals 5. But that's not our answer. They want the length of AB. So if x is 5, and AB is 4x, then AB has to be, the measure of AB has to be 4 times 5, which is 20. Does that give the angle on our test? Sometimes we have to plug it back in. Okay, so what is QR? Well, let's first make sure we actually use our theorem. Here we have a bisector. How do we know S is a bisector? Check mark, here and here. So we don't know whether that S is a midpoint, and connected makes a bisector. And it's a perpendicular bisector, so we can say any point, following with this, any point on this perpendicular bisector, if I connect it to the endpoints P and R, then that side has to be congruent to that side. So find N first, and then plug it in to answer the question, the length of QR. Find N first. Work it out on your paper. Find what N is, the value of N, but then you have to remember to plug it in. Find the value of N, set it up. Then you have to plug it in. N. For N, as in Nancy. N, 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 N. Not a final answer, just N. 3. Good. And then once you get 3, you plug it back in. QR is here. So 5 times 3 minus 7 is what? 8. So QR, the measure QR is 8. Okay? Okay, flip it to the back. Let's not do that one. Let's go down to these angle ones at the bottom. Okay, so we just, the particular bisectors, now we're doing the angle bisectors. Find the length of RN. Well, let's see if we can use our new theorem. For RN, looks like we'll have an angle on the side in the middle. How do we know that this is an angle bisector? How do we know it's in the middle? Is there any markings that tell us it's exactly in the middle? The arc thingy. There's an arc here and an arc here. So it tells us those angles are congruent. So it's an angle bisector. And then we see a right intersection, a perpendicular intersection, and a perpendicular intersection. So this blue piece and this blue piece have to be equidistant. What does equidistant mean? Equal. Right? Equidistant means equal. So let's put them equal to each other. 7x equals 2x plus 25. Equidistant means equal in distance. So we can set them equal to each other. Find x and then plug it in. So what is x? The value of x. Good. 5. So we plug it in, we do 7 times 5 for the measure of MR or RM. Do you all get 35? Okay. So, before I send you out in the hallway, we're going to get you a volume 2 version of the book. Let's write down what our homework is. And guys, if you pay attention to the theorems, this homework's not too bad, is it? Okay, we're going to do it on the 2 different pages, then I'll get you a question in a little bit. Okay, write this down, please. You should have some place to write your homework down every day. Okay, we're going to do numbers 2 through 12 on that page. That's on the mid segments of triangles. You should go through those. And then the second page on the bisectors starts on page 538. Okay. Just 1 second. And that one's going to be 2 through 20 even. Okay, now I'm going to send you out into the hall, and you're going to sign up, and you get your book. In the front side, you need to, in the front cover, the front areas here, I'm showing you, so look this way. You need to put your name and class period. You need to sign this log that you received one. I don't have 2 logs, but you only have to sign 1 of them.